Yeah, good evening and welcome to another Depsys Café. Today we're going to talk about scalable grid edge computing, and but first let us do some introductions. So my name's Gordon Fairley, Business Development Director for Depsys, and Philippe.
Good evening, my name is Philippe Grosjean and I'm a CTO at Depsys.
Yeah, very good. So obviously to put things in context for grid edge computing and what we're going to be talking about today, first we need to set up some of the challenges that are being experienced in the grid today. So effective solutions require digitalization of the electricity grid. On the left you see climate change, obviously a very significant topic, and we see a lot of climate-based events throughout the year now, many different activities ongoing to try to target those and improve situation across the world. These are putting stresses on the grid, increased variable renewable energy share, electrification of society, with EV being one of the major changes that is happening, but the overall energy transition away from fossil fuel towards electricity. Energy hungry industries are continuing to grow. Climate events, as we managed, we're seeing more and more around the world. One of the interesting facts, of course, is that as many of the countries get warmer, we saw this recently in California, people are actually turning their air conditioning units up. So actually the demand for electricity is increasing and putting further stress on the grid, as well as the other climatic events where grids are being impacted by massive snowstorms like the one we saw in Texas, that took out the part of the Texas grid a couple of years back. Infrastructure aging, of course, is part of a major topic worldwide, where assets are typically in the 40 to 50 year age range. So a number of stresses on the grid. And the outcome for that is impact on the grid, such as outages, where we're seeing a lot of new outages being created. Obviously, some outages are created through storms or through human error, such as digging up a cable in the street. But also there are increasing number of outages coming from asset aging impact, and also stresses on the grid. Finally, power quality violations are increasing as more demand goes onto the grid. And then what we've seen reported from many countries and many grid operators, congestion is a major problem that's now being faced. Particular example that's public and out there, if you want to go and Google it, is Netherlands, where they're having severe issues with grid congestion at the moment and working to facilitate how to resolve those situations, using, for the most part, technology and getting better understanding on the grid. So what we say is the grid edge unlocks the insights necessary to provide, for example, flexibility, interaction, insights into what's happening on the grid. And we believe that as you grow, as we'll look at the moment, the grid edge is really the place where a lot of this work needs to happen. And then the benefits of grid edge computing and gaining insights at the grid edge is going to be a critical factor in helping resolve or meet some of the challenges that are mentioned on the chart here. Okay. So edge computing, what do we mean by edge computing? Also, there's a lot of discussion still in the industry, so it's a term that's used widely for a lot of different types of edge computing. To put it in context, in the distribution grid where Depsys is active, so our solution grid eye goes into the secondary substation, primarily in the distribution electricity distribution network. But if you look at the overall electricity distribution network, you have primary substations where starting to see deployment of rugged PCs. Similar to other industries, rugged PCs are being used. Rugged PCs tend to be highly performant devices, which you're running as virtual machines. They're basically regular PCs, highly performant regular PCs, ruggedized. Again, because of the number of primary substations on a typical grid. So along the bottom axis here, you see a typical grid with, in this case, 2 million end customers. So for a 2 million end customer grid, you might have around 200 primary substations, but you would actually have 20,000 secondary substations. And then beyond that, you would have distribution of street cabinets. And so you see a lot of, basically the scale here is what Depsys is targeting. I will talk about the solution, gridized solution. So that's why we refer to scalable, that we're having a solution for scalable grid edge, where you have the compute capability, but you're also doing the data acquisition. So you're not just doing the compute, you're doing data acquisition at the same time. And you're doing that in a scalable way that can be deployed widely across the network. If you go on the far side, smart meters, obviously many networks have deployed. Some countries have 100% deployment of smart meters. And again, smart meters being used for increasingly for processing of data. And then further out, of course, then there's the IoT devices that are being used and a much more ubiquitous, but in terms of capability, performance, obviously they're limited in terms of what they can do. So it's kind of full, as we might call continuum, but each has to live on its own. And while some of these markets have developed more quickly than others, we see now increasing interest at customers for a scalable grid edge solution at the secondary substation. So coming on to edge computing use cases, Philippe, want to take us through this?
Exactly. So on this slide, okay, we try to really categorize all the use cases as a benefit of edge computing into 4 categories. The top 2 ones, 1 and 2, are really about, allowing the possibility just to develop intelligence, so pre-processing, processing at the edge. And the bottom ones, 3 and 4, are really about, operational intelligence, where above pure processing, we are talking here about being able to control also and interact with existing assets. So if we go and give some example for the 4 categories, if you look at category number 1, custom data formatting, it sounds pretty obvious, but offering the possibility for third party to, and this is the benefit of the open edge computing, offering the possibility for third party just to develop their own data strategy at the edge. So just to avoid to transfer a large set of data, for example, to the cloud to be processed, but already implementing pre-processing at the edge just to build your own KPIs or doing specific filtering, analyzing, for example, already waveforms and extracting key information from that is already a significant benefit. Second one is about to embed your own analytics. So already identifying some key trends, running some specific algorithm. So as we'll see in the next slides, Depsys has developed over the year a large set of analytic algorithms related to grid performance. But here we're offering also the possibility just for third party just to embed their own IP into the system. So again, here it's what category 1 and 2 are really about pre-processing data and processing the data at the edge. If we are zooming in now on category 3 and 4, here it's really about being able to interact. So for example, once you have the information at the edge and probably coming from the information we mentioned above, analyzing the data and the behavior of your grid, having the possibility, for example, to interact with the assets, for example, taking actions in conjunction with existing RMU, or in this example, we are talking about public lighting, but also possibility to interact with solar panels or EV chargers or whatever energy asset you can find is also a plus. So here we are talking about active management at the edge. Distributed control here, it's a benefit of having like local intelligence at the edge, but also having the possibility to interact with the central intelligence. And for example, in that case, define some strategy to avoid congestion or voltage variation. So really being able to dynamically, actively control the grid to fit and manage performance, targeted performance for that.
Okay. In terms of grid edge computing deployment status, nearly half of our customers started a grid edge computing strategy, either with scalable grid edge approach or embedding edge computing in smart meters. So we talked to our customers. We've been talking to customers over the last number of months, and we did some surveys and polling. So this is a result, what you see in the chart of that. That they have been working towards looking at grid edge deployment. Excuse me. Less than a third, though, is prepared for executing skills at the grid edge. Philippe?
Yeah, so now if we're looking at how Depsys is implementing this open edge computing, so Depsys solution is covering the full scope. So from edge devices, so what you have on the left-hand side of this slide. So for example, okay, we have a range of devices with having an open platform for edge computing. So we have the possibility to embed like, let's say, IT environment. So being able to, for a third party to program their own strategies, their own intelligence, on the Linux platform using, let's say, IT languages, something which is familiar, and or the possibility for other skill sets, for example, engineering teams that are comfortable with PLC programming. For example, just to program, the intelligence using PLC programming language and download that on the platform. So at the grid edge, basically, we have the ability to process local logic. So we have Depsys system logic, a standard feature at the edge, but we're also offering the possibility for third party to embed their own IP in very familiar environment for the IT world. And then on the cloud side, we have like cloud-based application, and from the information collected at the edge, we can, with a context, we can implement another layer. For example, a simple example, we can embed information coming from GIS system. So at the edge, we'll have a set of algorithms that will allow us to detect fault on the grid. And by combining the information, overlaying the information from the GIS, being on the cloud side, just to determine the exact location of the fault that the edge is providing. So it's what we call the contextualization of the information. And from that, we have an open platform also on the central side, where we can establish connection, as I mentioned before, with GIS, but not only existing SCADA system, ADMS, or other applications, third-party applications. So we have a range of API also that will allow anybody just to take advantage of the information provided by Depsys. So what we have been able to experience now, the benefit of edge computing for grid management, clearly, as I mentioned when I introduced the different category of edge computing. So first, it's linear data communication. So you don't have to transfer massive amount of data. So especially, for example, if you are having algorithms that are that wants to analyze waveforms, for example, to determine harmonics and so on. You just need to process the information at the edge and transfer only what you need on the cloud. So we saw, for example, like sampling on 2 terabytes of data going down to less than 45 megabytes. Useful information for the cloud. It's also obviously helping to reduce latency, so to be reactive, and especially if you want to implement like active control. So you are falling into the control or distributed control strategy that can be executed at the edge. It's allowing you also to avoid, all unnecessary trouble or latency linked to the networks, where you have full autonomy and you have a secured device to operate at the edge. Next slide, Gordon.
Yeah, and I think this was the last chart, but just to elaborate a little bit on some of the topics you touched on, Philippe. But I think the fault management, fault identification and localization is a fantastic example. And again, it's an algorithm, a grid edge algorithm that runs at the grid edge on the device at the grid edge is highlighted here. And then we take that data and we can textualize it in the cloud. And I think these aspects are very critical. A good example of the benefits of doing grid edge computing in terms of allowing us to get insights at the grid edge, using advanced waveform analysis at the grid edge, but also doing that in a scalable way that allows us to then populate the device through into the secondary substation and the number of secondary substations that are typically seen on the network. So it's really an opening that we've been taking advantage of for a number of years doing grid edge computing, and now with the latest advent of the technology, we're opening that up, as Philippe mentioned, so that sort of embracing both IT and OT programming and enabling our customers to develop code and algorithms that they could place at the edge, or in fact, they could bring third-party algorithms that they wanted. So if a network operator had a specific focus area, for example, energy theft, and they wanted to develop a specific algorithm for their network, they could do that, and they could do it at the grid edge, which we see as being a very powerful opportunity for them, because not only do they benefit from the things on the side of the chart that are mentioned here in terms of reduced data rate back to the cloud, in terms of resiliency, but they also are able to take advantage of working with very high quality data at the place where the data is collected. I think another area that's of interest that's being discussed is, for example, doing things like running real-time digital twin distributed at the grid edge. And so you could actually place your digital twin at the grid edge and then update it continuously based on data at the grid edge. And in that way that you would actually have a very up-to-date digital twin, which would in turn help things like improve forecasting models within the network. So really a lot of opportunities to come from the technology, and a lot of flexibility. And it also, one key aspect that we've been discussing with our customers is many customers would like to avoid vendor lock-in. And so by having an open platform that touches on things, as we talked about, including towards LF energy, it provides them with a platform where they can introduce their own algorithms or third-party algorithms, and thereby avoiding having installed a piece of hardware from Depsys. They're not necessarily limited just to using Depsys algorithms as we go forward. Okay. So yeah, I think that's all we had for today's presentation. I hope you found it interesting. Any closing comments, Philippe, before we wrap up?
No, I mean, all good.
Yeah.
Thanks.
Very good. Okay. Well, thank you for your time today, and we look forward to talking to you in the future. Very good. Thank you very much.
Thank you.